Okay, we are in section 3.2 where we are continuing solving systems of linear equations. This time it's not by graphing, but it's solving things algebraically. You can solve things algebraically in two ways, one of which is called the substitution method, and the other one is called the elimination method. We did something like this in beginning algebra, so some of this will be reviewed. If we're planning on solving a system using the substitution method, the first thing we have to do is find a solution for the given system. Well, you're going to find the solution of the given system for just like we did graphically. You know, the intersection of it was an ordered pair. You're going to find an ordered pair here as well. In order to do that, there's some steps we have to follow. So first step is we solve one of the equations for one of its variables. I noticed that looking at the first one here, where I have 2x plus 5y equals -5, and x plus 3y equals 3, the easiest one to solve for one variable would be this one, and I want to solve for x. So to get x by itself, I'm going to subtract 3y to both sides, so that leaves me with x equals a -3y plus 3. Second step is I want to substitute the expression into the other equation and solve for the other variable. So I noticed that I'm looking at this equation right here. I know that x equals -3y plus 3. And I also see that I have an x in that equation. So what I'm going to do is I'm going to substitute x in for -3y plus 3, and then I'm going to solve for y. So I got 2, and then where I see x, I'm going to plug in -3y plus 3, because that also equals x, plus 5y equals a -5. Now I'm going to distribute the 2, so I got -6y plus 6 equals 5y equals -5. From here, this is where I can solve for y. So I'm going to combine like terms here. I got -y plus 6 equals a -5. Subtracting 6 to both sides, I got -y equals a -11. If I divide both sides by -1, y equals 11. So I find that my first variable y was going to equal 11. Last step is you're going to substitute in that number in for the variable and then solve for the other variable. Either equation works. Doesn't matter which one you use. Both of them should work. I'm going to use the second equation, the x plus 3y equals 3. So I'm going to go x plus 3, but instead of putting y in, I'm going to substitute in my 11 because I know y equals 11. And that equals 3. So x plus 33 equals 3. Subtracting 33 to both sides, I get x equaling -30. Now to prove that those things are correct, I just substitute in my x and y to see if they work for both systems. They do. If you're looking for additional examples, I'll do one more. Let's say I had a system like 4x plus 3y equals -2. And let's say I have x plus 5y equaling a -9. Again, I'm going to try to solve for one particular variable on one equation. I noticed that the easiest one would be the second one, and I'm going to solve for x. So here my x would equal -5y minus 9. So now from there, I'm going to substitute, that's why they call it the substitution method, into that first equation here, and then I'm going to solve for y. So I'm going to say that this here was going to be 4 times negative 5y minus 9, because that's also x, plus 3y equals a negative 2. So I'm going to distribute that 4, so I got negative 20y minus 36 plus 3y equals negative 2. I'm going to combine like terms, so I got negative 17y minus 36 equals negative 2. So I got negative 17y. I'm going to add 36 to both sides. This equals, what, 34? And my y here is going to equal a negative 2. So from there, I can substitute in a negative 2, and for y, I'm going to use that second equation to find what x equals. So I got x plus 5y equaling negative 9, but I know that my y is negative 2, so I'm going to say x plus 5 times a negative 2 equals a negative 9. X minus 10 equals a negative 9. Add 10 to both sides. X equals 1. So my ordered pair in this case would be negative, or positive 1, I'm sorry. Positive 1, negative 2. And if you were to graph this, that's where the two lines would intersect. The second method is the elimination method. So again, we're still trying to find a solution. It's exactly the same, we're trying to get the exact same result as we were doing with substitution method. We're just doing it another way. First off, I have the equation 3x minus 7y equals 10 and 6x minus 8y equals 8. First step I want to do is multiply one or both by a constant, which is a whole number, to get the opposite coefficients with one of the variables. So here's what that means. So I see that I look at my 3x minus 7y equals 10. I'm going to pay attention to my 3x. The reason why I'm going to pay attention to my 3x, because if I multiply by a negative 2 to the entire equation, I'm going to get a negative 6x, which will also match up, which would be the opposite coefficient of one of the variables. So that's what I'm going to do. So I'm going to say I got 3x minus 7y equals 10, and then I got 6x minus 8y equals 8. So if I want to multiply this one equation to get the opposite coefficient, I'm going to multiply that first equation by a negative 2. And by doing that, I have to distribute that negative 2 to the entire equation. So this is going to be negative 6x plus 14y equals a negative 20. I keep the same equation on the bottom, 6x minus 8y equals 8. So now I see that I have an opposite coefficient of a negative 6x and a positive 6x. So from there, we're going to add the equations together. By adding equations together, we can combine like terms, which would eliminate one variable. Solve for the other. So I'm going to go, I got negative 6x plus 14y equals negative 20. And I got 6x minus 8y equals 8. So they want me to add the equations together. So using like terms, negative 6x plus 6x would give me 0. So I'm just going to leave it blank. 14y plus a negative 8y will give me 6y, which now equals negative 20 plus 8 would give me a negative 12. Now I need to solve for the other variable, which happens to be y. So I'm going to divide 6 to both sides, which gives me y equals a negative 2. Once we do that, we can do the exact same thing as we did up in the substitution method. We just substitute the value for the variable into the original equation and then solve for the other variable. So we've got y, we need to solve for x. It does not matter which equation you use, you should get the exact same value for x for each one of them. So let's just say, let's just use 3x minus 7. Since y is negative 2, I'm just going to plug it in, equals 10. So let's just do that. So from here, I got 3x and negative 7 minus 2, give me a plus 14 would equal 10. I'm going to subtract 14 to both sides, which gives me 3x equals a negative 4, and my x will equal a negative 4/3. So my ordered pair here will be negative 4/3, comma, a negative 2. See, that one would be kind of tough to pinpoint or estimate while graphing, so that's why we do solve things algebraically. If we're looking at another example, so let's say I had 3x plus 3y equals a negative 15, and I have 5x minus 9y equals 3. So they want me to eliminate one of them. I notice that I have, if I were to multiply 3 to my top equation, I could eliminate my y because I'd have the opposite coefficients of 9 and negative 9. So that's what I'm going to do. I'm going to multiply this whole thing by 3. So then that would give me 9x plus 9y would equal a negative 45. And then I just leave the same thing on the bottom, not multiplying anything here. So what I'm going to do is I'm going to add both of them together. So 9x plus 5x will give me 14x. And these two cancel out to be 0, equals negative 45 plus 3 will give me a negative 42. So I'm going to divide both sides by 14, and this gives me x equals negative 3. So now what I do is I'll plug it back into the original equation. I'll just use this one here. So I have 5 times negative 3, because that's my new x, minus 9y equals 3. 5 times negative 3 is negative 15, minus 9y equals 3. I'm going to add 15 to both sides, so I got negative 9y equals 18. And if I divide both sides by negative 9, I get y equals a negative 2. So my ordered pair here would be negative 3 comma negative 2. It's very important to make sure that you always have your first number to be x and your second number is y, because if you mix them up, you're going to have an incorrect solution and wouldn't work for your system. So make sure you're careful when you're writing those equations. There are some special circumstances where you're going to get infinitely many solutions, where, again, what we talked about in previous sections, where when you boil it down into y equals mx plus b, they're the same line. Or you're going to get something that has no solution. So I'm going to show you an example of what both of them look like. So let's just say I have a system like x minus 2y equals 4 and 3x minus 6y equals 8. Something to that matter. What you can do is You can pick either one, substitution method or elimination method. Does not matter what you choose. For this one personally, I'm going to choose the substitution method. So I'm going to solve for x for this variable. So, or for this equation. So I'm going to go x equals, I'm going to add 2y to both sides. So I got x equals 2y plus 4. So I'm going to go back and I'm going to put x into this equation. So now I have 3 times 2y plus 4, because that's x, minus 6y equals 8. So I'm going to distribute, so I got 6y plus 4 minus 6y equals 8. I see that I have like terms. I got a 6y minus 6y, which would give me 0. So it ends up I have 4 equals 8. Obviously, 4 does not equal 8. So when you come across a system that ends up giving you an equation that's not true, that means that those two lines are parallel. Those two lines will not have a solution. So this one here, we can conclude it has no solution. If I have another system, say I'm going to put down 4x minus 10y equals 8, and then I have negative 14x plus 35y equals a negative 28. So, what can I do with this one? What I'm planning on doing is, in order to get cancellation, I'm going to pick on my x. I want to eliminate my x, because what I can do is I can multiply this by 14, and I can multiply my bottom equation by 4. By doing that, by multiplying both by each other's coefficients, they're going to end up being the same value, so I can cancel them out. So if I distribute 14 to the first equation, I have 56x minus 140y equals 112. Now for the second equation, I'm going to have negative 56x plus 140y. Wait a minute. Equals sorry about that. Where was it? Okay. I want to now multiply 4 times negative 28, which then that gives me a negative 112. So if I add this together, this gives me 0. This also gives me 0. And this gives me 0. So here I have 0 equals 0. If they end up making a true statement, that means that the two lines would overlap, so then we'd get an infinitely many solution, or all real numbers will work. And that is solving systems of linear equations by graphing. Hope this helps. Until next time.